Hey, Algebra 2. So something I pointed out in our first video is that it's actually really easy to multiply numbers underneath square roots. You can always multiply two square root numbers together. So for instance, if you have like the square root of some number times the square root of some other number, maybe the square root of 9 times the square root of 4, you are always allowed to multiply two numbers underneath the square root together and just say, okay, square root of 9 times the square root of 4 should make the square root of 36, which happens to just be 6. And I can prove that that works because I can say, well, I know that the square root of 9 is 3. I know that the square root of 4 is 2. 3 times 2 is indeed 6. This works perfectly well with division also. You are allowed to say that any square root number divided by any square root number is just the square root of that quotient. So for instance, if I had the square root of 100 divided by the square root of 25, it is perfectly fine to just say, okay, well, what is 100 divided by 25? 100 divided by 25 is 4, so this should just be equal to the square root of 4, which is 2. And again, I can prove that that works because I know that the square root of 100 happens to be 10. I know that the square root of 25 happens to be 5. 10 divided by 5 is 2. So square roots are really easy with multiplication and with division. You're literally always allowed to take any square root number and multiply it by any other square root number, take any square root number and divide it by any other square root number. What I wanted to focus on today is that it's not that easy with addition and subtraction. And I can pretty easily prove to you why. Let's say I took like the square root of 9 plus the square root of 4. If we were just taking guesses as to what that was, you might guess, oh, can I just add those together? Square root of 9 plus the square root of 4, 9 plus 4 is 13. Maybe that should be the square root of 13. But if you think about that for a second, that's clearly wrong. The square root of 9 is 3, the square root of 4 is 2, so these add up to 5. The square root of 13 is definitely not 5. The square root of 13 is like 3.6 something. So it turns out that you are not allowed to add two square roots together or to subtract two square roots together. And instead, what we do is we simplify our roots and we combine like terms. So that's most of what we're going to be practicing today. It is totally fine to multiply two square root numbers together, totally fine to divide two square roots together, but if you have an addition or subtraction problem with roots, you cannot just add or subtract your roots. We need to follow this simplify and combine method. So we're going to see some practice problems with that today. Okay, so for our first example, let's say that I asked for us to add the square root of 18 and the square root of 8. Okay, so the first thing I want to point out is there is something that is definitely not the answer to that problem. The answer is definitely not going to just be the square root of 26. You cannot do that with square roots. You cannot just add them together. But what we can do is simplify the roots. And so when I say simplify the roots, what I mean is make a tree of the roots, right? So see if there's anything you can pull out. So with 18, I can say that's 9 and 2, 3 and 3 and 2. So I have the square root of 3 times 2, and I can use that trick we've been talking about. A pair on the inside is as good as 1 on the outside. So this simplifies to be 3 times the square root of 2. Okay, and with 8, I know that if I make a tree for that, I've got 4 times 2, so I've got 2 times 2 times 2 as my prime factorization. 2, 2, 2. A pair on the inside is as good as 1 on the outside, so I can pull 1 2 out. This is 2 times the square root of 2. So I've simplified my two roots, and here's what I mean by combine like terms. I don't know what the square root of 2 is exactly. In fact, no one does. It can be proved that the square root of 2 is a decimal that goes on forever and ever and ever, never repeats itself. It's a crazy number. So we don't really know totally the square root of 2. It's an unknown, very much like a variable. So you can actually think of this problem as being a lot like 3x plus 2x. That is to say, the square root of 2 is a number I don't totally know or understand, kind of like a variable, like x. But if I've got 3 of that weird number and 2 of that weird number, together they should add up to 5 of that weird number. much like 3x plus 2x would be 5 of x. So I was basically able to say this is 5 times the square root of 2. That is the simplest possible answer for what root 18 plus root 8 is. Okay, I'm going to do another problem like that. This one's going to have more roots in it. And if you're feeling confident, you might want to try to pause the video after I put the problem up and try to simplify all the roots yourself. So the problem we are going to do is 7 times the square root of 45 plus the square root of 7 minus 3 times the square root of 20 plus 5 times the square root of 28. So there's a whole bunch of numbers there, and I cannot just add and subtract the roots together. I can't say that like root 20 plus root 28 is root 48. That's not allowed. But I can simplify all the roots and combine like terms. So I'm going to do this fairly quickly, but I think you guys know this pretty well by now. I'll say that's 9 times 5, 3, 3, 5. So I already had a 7 on the outside. A 3 pair on the inside becomes a 3 on the outside. And I'm left with a 5 underneath. So I already had 7 outside. I pulled out a 3. This is going to become 21 times the square root of 5. Square root of 7 does not simplify, so that's just going to become plus a square root of 7. Okay, but the square root of 20 does simplify. I know that that has in it 4 times 5, so 2, 2, 5. So I'm going to be able to pull out a 2, and there's going to be a 5 that stays inside. So I have minus 3, a 2 comes out, and then I still have root 5 underneath. This is going to become minus 6 times the square root of 5. And then lastly, for my last root here, I know that 28 can become 4 times 7, so 2, 2, 7. I have a pair of 2's on the inside, so there's already a 5 outside. A 2 comes to join it. And then square root of 7 is left underneath. So this is going to become plus 10 times the square root of 7. I've simplified every single root, and then if I have like terms, I'm allowed to combine those. So for instance, I have 21 root 5's minus 6 root 5's. That's very much like 21x minus 6x, because root 5 is a weird number I don't totally understand. So I could say, okay, if I said 21 of the weird thing minus 6 of the weird thing, that's 15 of the weird thing. 15 times the square root of 5. And then with the root 7's, I have 10 root 7 and then 1 extra root 7 here. This is very much just like an x by itself. It's like 1x. So I had 10 of this weird thing, 1 of this weird thing. That gives me 11 of that weird thing. I can't combine these two things together because they're not like terms. Much like if you had 15x plus 11y, you couldn't combine them. So this is as simplified as this expression gets. I simplified every root and then I combined like terms. Okay, so if you guys now understand both how to multiply roots and how to add and subtract roots, the other thing I think that you guys are now ready to do is FOIL some expressions with roots in them. And so we're going to do just a little bit of practice with that as the other part of today's lesson. So I'm going to give us a kind of intimidating looking foiling problem. That is to say, we are going to be multiplying a binomial, something with 2 terms, times another binomial, something else with 2 terms. Here's what it's going to look like. 5 plus 2 times the square root of 3 is going to be multiplied times 2 plus 4 times the square root of 3. So I said this was a foiling problem, by which I mean we're going to have to multiply the first terms, the outer terms, the inner terms, and the last terms. And so we're just going to go step by step here, remembering you can always multiply a regular number with a regular number. You can always multiply a root number by a root number. So I'm going to start here. I just have regular 5 times regular 2. That just makes regular 10. Okay, so now for my outer terms, I have 5 times 4 root 3. The deal is you can always multiply 2 regular numbers together, and if there's a root there, it just comes along for the ride. So 5 times 4 makes regular 20, and then square root of 3 just comes along for the ride. I do not multiply 5 times the root 3 because this is a regular number and that's a root number. All right, if I keep going here, I've got 2 root 3 times 2. Same deal. Regular number times regular number makes plus 4. And then the square root of 3 just comes along for the ride. This 2 does get multiplied by that 2, but it does not get multiplied by the root 3 because that's a root number. And then lastly, the last piece of this is going to be the most complicated. I have 2 root 3 times 4 root 3. So I'm going to start with multiplying my regular number by my regular number. 2 times 4, that makes 8. Then I have root 3 times root 3. Root 3 times root 3 should make root 9, which if you think about it is just equal to 3. The square root of 3 times the square root of 3 is the same as square root of 3 squared, just becomes 3. So this back term, 8 times the square root of 9 turns into 8 times 3, turns into the regular number 24. So if I sort of take stock of everything I have here, my first term is a regular 10, my last term is a regular 24, so I can add those together to get 34. And then my inner 2 terms both have weird gross decimals that go on forever, but they're the same type of thing. This is very much like having 20x plus 4x. I can make this 24 times the square root of 3. And that's as simplified as the answer to this question gets. I combined all the regular numbers I could, and then I combined all of the roots that I could. Okay, let's try another foiling problem just to keep practice with this. Let's say that I gave you the problem 2 plus the square root of 7 squared. Now you might be thinking, Miss Ball, I thought you said you were giving me a foiling problem. That's not a foiling problem. Well, what I want to remind you of is you're always allowed to distribute an exponent over multiplication, but not over addition. I'm definitely not allowed to just square the front and square the back here. What I have to do is I have to write this out as, what does it really mean to square? 2 plus the square root of 7 times 2 plus the square root of 7. I have this quantity times itself. And so when I go to do this problem, I do have to FOIL because I have 2 terms times another 2 terms. So let's go through this step by step. The front terms, 2 times 2, that makes 4. My outer terms, I have a regular 2 times the square root of 7. I can't actually combine those two, like I can't make it like root 14 because they're not both root numbers. So I'm just going to smush them together. This becomes 2 root 7. It's exactly the same thing with my inner terms. I have a root number and a regular number, so the best I can do is smush them together. This becomes 2 root 7. And then in the back, which is usually where you have the most interesting part of the problem, I have root 7 times root 7. That's going to make root 49, which happens to just be regular 7. Because the square root of 7 times the square root of 7 should make 7. So again, I'm going to combine my regular number with my regular number. 4 plus 7 is 11. And then I can add these 2 root numbers together. 2 root 7 plus 2 root 7 becomes 4 root 7. That is as simple as it gets. Not that this problem is simple as it gets. That problem was actually kind of hard, but that's as simple as the answer can get. Okay, we're going to race to put one more of these in, and then you guys will be all set to do some practice problems. So, last problem of the day. Let's say that you guys were looking at 8 plus 3 root 5 times 10 minus 2 root 5. So, yet another foiling problem. 8 times 10, regular times regular makes 80. 8 times negative 2 root 5 makes negative 16 root 5. 10 times 3 root 5 makes plus 30 root 5. And then it's always the back where you've got to be really careful. This is going to make negative 6 times the square root of 25, which is negative 6 times regular 5. The back turns into negative 30. So if I quickly combine here, 80 minus 30 makes 50, combine my two root numbers, I have plus 14 times the square root of 5. Good luck with your